Can you see my screen?
Yes.
Okay, great. So we are going to be doing inverse of a function. So basically, what they mean by inverse of a function is that if you have a function, um, let's say y equals to 2x. What happens now when you want to find the inverse of this function is that you're going to swap the position of the x and the y. So your y becomes your x then becomes your y. They swap positions, right? So this is how you'd go about finding the inverse. So it's going to be, see how you had a y, now you're going to write this y as an x. So it'll be x equals to 2y. Fine. You've completed the task of swapping the x and the y, right? But even after swapping, you need to put it in a standard form of a function. And the standard form is that um, you'd have to divide both sides by 2y to make the y the subject of the formula, right? So you divide this by 2, you'd also divide this by 2. These two will cancel one another. So you're now going to have y equals to x over 2. This right here is the inverse function of this right here. Do you get that?
Yes.
Okay, fine. So, what we need to know about an inverse function is that an inverse function, I'm just going to write an inverse function. It's a mirror, it's a mirror image of the initial, like it's a mirror image, like slash reflection over the x, over the y equals to x. It is a mirror reflection over the y equals to x. Okay, fine. What I need you to understand by this is that, um, okay, let's say we have a function, right? Let's name it 1. And it's like this y equals to 2x raised to the power 2. Fine. If you're trying to get the inverse, how an inverse is denoted is written like this, right? If we're trying to get the inverse of this, we have to swap their positions. So we'd have x equals to 2y squared. But again, we need to make this y the subject of the formula, right? You divide this by 2, divide this by 2, this and this will cancel. So now you're left with what? X divided by 2 equals to what? Equals to y squared, right? But because this is y squared, you can't work with this. You need to what? Introduce the square root on both sides, right? So this would look like this, and then this would also look like this. These two are going to cancel one another out. So you're now left with what? Y equals to root x over 2. This is how you'd find the image of this. But what I wanted to show you is that, what do I mean by this, right? So let's say you have a parabola. Ne? Your parabola, it's of this shape, right? If you were to find the if you were to find the inverse of this function, and then you'd have to plot it down, this is sort of the shape that it would take. It would look like this. And what did I mean that it's a, wait, what what did I mean? Remember, this over here, it's the y equals to x line, right? So if you were to draw a straight line cutting through like this, let's just assume it's straight. Nah, fine. And then you take this parabola over here and then you fold it like this, like you fold it onto the middle of this line. This would look like this side. They're going to be identical. It's just that on the opposite sides of this y equals to x margin. Do you get that?
Yes.
Okay, great. Same way, let's say you have an exponential function, right? And, sorry, let's say you have an exponential function. You have Uh, okay, let's just put the general form of an exponential function. If you have y equals to ax, right? This is your exponential function. We said that if we want to have an inverse, what do? We swap the y and the x, right? So you're going to have x equals to a raised to the power y, right? But because we want the formula to have y as the subject of the formula, we have to find a way to bring this, sorry, we have to find a way to bring this down, right? So what can you do if it's like this? What you can do is introduce logarithms, right? So this would be the log of x equals to the log of a raised to the power y. Now, when you introduce a log and something is raised to the exponent, this exponent will come down. That's what the log does to the exponent. So we'll have log x equals to y multiplied by the log of a. And now, if we want to make y the subject of the formula, sorry, we can just divide both sides by log a. Divide this by log a. These two will cancel one another out. So if you have like this, right? If you have log x divided by log a, you can simply just write what's in the denominator, this a, as the base, right? So you're going to have, okay, fine, these two have canceled one another. So you can just say y equals to, this is what I mean by writing the a as the base. You're going to have log a x, like that, right? Okay, now let's say, because we know that the shape of an exponential function, the normal one, it goes that way, right? What I mean by an inverse, the direction of the inverse, sorry. Remember, we said an inverse, it's the mirror image upon the y equals to x line. So if this is your, what do you call it? If this is your exponential one, higher so we had already started with inverse of functions, right? So if this is your original function, right? This is your f of x, your f of y. Remember, we said it's a mirror image along the y equals to x line. So it means that if this is going that way, your mirror image will come this way. So the mirror image will look like this. I mean, it makes perfect sense because if you were to fold it down, you would get this eventually, right? I just need you to note this down, right? And remember, we said that mm, mm, um mm, okay, let's redraw the parabola again. Let's say we have a parabola and it's like this. Um this is f of x, right? And we know that the inverse of f of x will look like this, right? Fine. Now let's look at the original, right? When you look at the f of x, the actual f of x, all right? Let me check something. Okay, when you look at the original, which is this one, right? The one that goes this way. Let's look at the domain. Remember, when we speak of the domain, we're talking about what? The x axis, right? Fine. Now let's look at the domain of this original f of x, right? We can see that it's coming from the negative infinity x-axis going all the way where? Going all the way to the positive infinity x-axis. So for the domain can exist. Sorry. The parabola can exist anywhere on the x-axis, and it's still going to be what? It's still going to exist because it does exist anywhere along the x-axis. So you're going to say X is an element of a real number. Like you could place this parabola at negative 100 on the x-axis, it's going to exist. You could place it at like positive 1999, it's still going to exist. So for the domain, you're going to say what? X is an element of a real number, right? Now let's look at the range, right? Let's look at the range. Okay, when you look at the range, ish, sorry, somebody's struggling to join. Let me just help them then. Give me a minute. Khumuri, so did you have a problem when you had to click the link of the group to just join?
No.
Okay, I don't know why are people telling me that they can't join. What? Excuse me, I just have to try and explain to them how they can join. What? What? Hey man, no, I can't understand what they mean. Okay, let's continue. Fine, let's go to the range, right? The range of the original parabola, right? When you look at the original parabola, you can tell that its range. Sorry, let me just go back to the question. Okay, when we speak about the range, let me just ignore this person. When we speak about the range of this graph, right, we're talking about all the possible y values that the function can take, right? And if we look at this parabola, it opens how? It opens upward, and it has a like it's the original, so it has a vertex way here at this point at 0, 0. So the smallest value of y, it's what? It's 0, right? So the range should be y greater or equals to 0. Over here at this point, that's where the range should be, because that's where your graph will be a positive. And remember that this graph, it's a positive. How do we know that it's a positive? Because it's an upward um, facing graph instead of it looking downward, right? Now, this is your domain and the range of the original one. Fine. Let's look at the domain and the range of the inverse, right? What you had as the domain, okay, let me just write the range. This is of the inverse, right? what you had as the domain in the original graph, you will have as the range. So basically, they swap, like how our x and the y's swap when we're trying to find the inverse. So see how this is the domain over here? When we come to the inverse, this domain will become the range. So we'll just say y is an element of a real number, right? And this range will now be what? Our domain. So you're going to say x has to be greater or equals to 0. And I mean, it does make sense. Let's look at our inverse. We're saying that for the domain, x should be what? Greater or equals to 0. Look at where the graph is. The graph, if they're saying x should be equal or greater than 0, I mean, that's true because our graph, our inverse function, it only exists where in the positive, it only exists on the positive x values, right? Because this side it's the negative x values. So if we're saying that it has to be greater or equals to 0, it could either be here or anywhere this side, but it cannot be less than 0 because it does not exist anywhere over here, only exists over here. Do you guys get that? And for the range, they said that y is an element of a real number. I okay, this is what we mean. Isn't it that when we're looking at this is just the graphical representation of what we have, right? Just in this margins. But we know that this is going to grow infinitely. Like it's going to go as high as it can get, right? And this is also going to go as low as it can get. So when this one goes up, it will keep on increasing its y values. So it might even go to like infinity y. It might hit infinity y. This might hit infinity negative y. So what we're saying is that even if it goes to infinity y or negative infinity y, it will still exist. That's what we mean. But I just wanted to indicate that the domain of the original, it's the range of the inverse, and the range of the original will be the domain. So they basically swap positions around. Do you guys get that?
Yes.
Okay, great.
Yes.
I'm going to send a question that we're going to do. This was inverse functions. Last week we didn't answer them. We didn't what do you call it? Not answer them. We didn't do it. So I wanted us to do it before we started doing functions questions. So I'm just going to send you the questions on the group. Be on the lookout, please. Let me just do this. Oh Lord. Mm, where are they? Yeah. Mm, forget out like I do. Okay. I sent the first one on the group. I sent the first one on the group now. Can you guys look at it? Okay. Okay, I was saying I've sent the first one on the group. Can you guys check it out? Tell me when you guys have found it.
I found it.
Okay, great. So on the question thing, they're saying we have two lines, right? Y equals to x plus 1 and y equals to negative x minus 7. They are the x's of symmetry of the function, that, right? And they said show that p is equals to 4 and q is equals to negative 3. Okay, fine. Before we even do that, let's identify the type of function that we have over here, right? That will be what? It will be a hyperbola, right? That function, the f of x. Can you guys see it? Sorry. This one. The f of x, it's negative 2 all over x plus p plus q. This is a hyperbola, right? Remember, we said a positive hyperbola takes this shape over here. But because this is a negative over here, it means which shape will it take? It will be in the this quadrant and this quadrant over here. Right. Now let's identify what is P and Q, right? We know that if we have a hyperbola like that, the P and Q are asymptotes. Like the P, it's our x asymptote, the Q, it's our y asymptote. Okay, so this P over here would be maybe an asymptote going that way. Am I lying? Yes, I am lying. The P asymptote, sorry, this P1 would either be like an asymptote over here. This would be our P. Along the x-axis, our asymptote there would be what? It would be P, right? So we know that as an asymptote, it's this what do you call it? Because it's not a solid line. It's like a dashed line, whereby our graph will like it will approach it, but it'll never ever like actually touch it. So this P, it'll give us the x asymptote, and this Q over here, it'll give us the y asymptote. So it could be like over here. It will be our Q. And we know that if this is our Q, this graph over here, it'll approach this, but it will never ever touch this Q over here. Do you guys get it?
Yes.
Okay. And um what else? Okay. So we're given the two straight lines, right? Okay. We're given the two straight lines and they're telling us to find what? The value of P and Q. So on a hyperbola, at the axis of symmetry, you will find like a point of intersection. That point of intersection will be your asymptotes, right? So this is what I mean by that. Let's look at this. We're given y equals to x plus 1, and we're also given, okay, let's just make this our equation 1, right? And we're also given y equals to negative x minus 7. Let's make this our what? Equation 2. Because we want to find the point of what? Point of intersection, what we can do is do what? Equate these two together. Because remember what I said? They said that these are our axes of symmetry, right? If we equate these axes of symmetry, we will be able to find out where they intersect. And where they intersect is the asymptote. Do you guys get that?
Yes.
Okay. So we're going to say x plus 1 equals to minus x minus 7. Then we have to group our x's. So this one we transpose it to that side, and this one take it that side. So we're going to have an x plus x equals to negative 7 minus 1. So we're going to have 2x or equals to negative 8. So we'd have to divide both sides by 2. This x will be equals to negative 4, right? So this x value, it's the, okay, this x value is the x value of your asymptote on the x-axis. But once you like plug it in there, it's going to change um a sign. Once you put it into the equation, it will change a sign, right? Okay, fine. So we got the x value of our x asymptote, which is what? we said that our P is our x asymptote. So we got the value of our x asymptote. Do you guys get that?
Yes.
But since where we have x equals to -4, when we substitute it in for P, we won't say x equals to -4. We're going to say P equals to +4. It's going to change signs. Do you guys get this?
Yes.
Okay, fine. So now we can just plug in our 4 into this equation over here, right? Um Wait a minute. Let me look at the question. I think I'm missing something. Okay, let me. Arrange. I'm struggling joining. Is the ready the meeting? Yes, the class is on. Ish, but what seems okay, I just need to look at something on the question, right? So they gave us that, they gave us that, and they also gave us that. Okay, fine. So we can just try substituting this 4 into the equation. So we're going to have y equals to -2, all divided by what? All divided by x. Because we said p, it's going to be a positive. So it will be x plus 4 plus q, right? Guys, can I leave the class? Then I'll come back because this person, they're trying to join. Just give me like 5 minutes to attend to them, ne? I'm so sorry. It's generally them.
No problem.
Okay. Hey guys, I'm back now. This person is probably toying with me because when I call them, now they're not picking up. Fine. Remember, we got our P, which our P is what? The X asymptote. Now we're looking for what? For. Wait. I need to record. Can you guys hear me? Hey guys, can you guys hear me?
Yes, we can hear you.
Um, hey guys, I'm back. So yeah, okay, let me continue. Hato, if you're here, there's somebody that's struggling to join the class. I told them to text you for help, so may you please help them out. That's if you're listening. So remember, we found our p value to be what? To be 4, and we said that the p was what? It's the x value of our asymptote. The p, it's the x value of the asymptote. So we only have the x. What are we left with? We need the y asymptote, right? Let me check if this thing is recording. Okay. We need the y asymptote, right? Fine. We had two. Where's that question? Where's that question? Oh no, over here. We have an x value, so we can substitute this p over into any of these two equations, get the y value. The y value that we're going to get will be our q. It will be our y asymptote, right? So we can let's substitute it into first the first one, the first function. So it will be y equals to 4 plus 1. So our y will be 5. So therefore, our q will be what? It will be 5. This is our y asymptote, right? So if it was us to draw this function, this is what it would look like. Because we just found out what our y, sorry, we just found out what our q and our p are, right? So we have y equals to -2 divided by x plus 4, um plus 5, sorry. This is our q and this is our p over here. So if it was required of us to draw, it would look like this. Okay, we have an asymptote here at x equals to -4, so it would be over here. It has to be a dotted line, by the way. This is our x equals to -4. And let's look at our y asymptote. This is our y asymptote. It will be here. Let's assume this is our +5, right? It would go all the way like this. And because we know that this is an exponential function, right? It means that this is the shape that it would take. It would go, one would be this side, and the next one would go all the way like this. Both these sections, they're doing what? They're approaching the asymptotes, but they're never ever touching the asymptotes. Do you understand that?
Yes.
Yes. Okay, great. So, what does the next question say? Can you read it out loud for me? What does it say? Because what does the next question say? Never mind. Um,
Emma
um,
pele question no Jeffing.
the one that we're currently doing. I think it's sending mo grupo. Yes, not I think. It's
Okay.
sending mo grupo. So let's go to 4.2. So 4.2, what are they saying? 4.2, they're saying calculate the x intercepts of f. So we know that y equals to -2 divided by x plus 4 plus 5, right? This is what we currently have. If they're looking for the x intercept, we know that for the x intercept, what do? You let y equals to 0, right? So we're going to have 0 equals to negative 2. Um, wait. Okay, negative 2 um, divided by x plus 4 plus 5. Now you have to transpose this 5 to the other side. So we're now going to have negative 5 equals to negative 2 divided by
Ubuti.
x. Yes?
Value of Q was -3.
Okay, negative 3.
Yes.
Oh, sorry. It means I made a mistake. Uh, yeah, it is supposed to be negative 3. Thank you, Ne.
Okay.
Oh, yeah, 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 yeah. Wait. Because remember our x, it's negative 4, right? Sorry.
Yes.
Yeah, this is negative 4 over here. So this would have to be negative 4 plus 1. It would be negative 3. Thank you, ne? So our x asymptote would be negative 3. I'll redraw this, ne? I'll redraw the diagram. Thank you very much. Thank you very, very much. So, wait. This is going to be minus 3. This will also be minus 3. So cancel this out. So when we transpose this negative 3 to the other side, we're going to have positive 3, right? 3 equals to negative 2 divided by x plus 4, right? Now we're trying to solve for this x plus 4. Make this a fraction, cross multiply, right? So we're going to have negative 2 equals to 3 all into x plus 4, right? Right? Yes. So we're going to have negative 2 over here equals to 3x for a 12 plus 12. Then we have to take this 12, take it to the other side. So we're going to have negative 2 minus 12 equals to 3x, right? It'll be minus 1, 4 equals to 3x, right? Now, for the x value, we would have to divide both sides by 3. So our x will be equals to negative 14 divided by 3, right? So this is our x-intercept, right? That's what they wanted in the question. So for the x-intercept, wait, what? We know that for the x-intercept, it's negative 1, 4 divided by 3 and 0. So this is your, um, that is your, sorry, this is your x-intercept. So we're done with question 4.2. Now let's look at question. Okay, for interest's sake, let's just also do the y-intercept, right? Uh, okay. We know that the function, it's just y equals to negative 2 all over x plus 4 minus 3. For y, let x equals to 0, right? So you're going to have y equals to negative 2 divided by 0 plus 4 minus 3. So what will your y be? It will be wait. It will be negative 7 over 2. So your y intercept, it will be 0 and what, and a negative 7 and a 2. So you have your x intercept over here. You have your y intercept over here. You know your two asymptotes. You know that p, it's negative 4. You know that q, it's what? You know that p, you know that q, it's negative 3. Is it positive or is it it's negative 3? So now we can actually draw this graph, right? Can I do this? Wait a minute.
The P it's a positive 4, not a negative 4.
Oh, okay.
Yes.
Hi, sorry, you were saying our P is.
It's positive 4.
It's a positive.
So,
Can you guys hear me?
Korea,
Yes.
yes.
Okay. P, it's a positive 4 when you um when you put it over here. But we know that the x value is what it's negative 4. But once you substitute it over here, it changes the sign. But when you plot, you use this x value. You don't take the p, you use the x value.
Mm,
Do you understand?
Okay, then.
So
Yes.
yeah,
yes.
just to clarify that. eh,
Yes.
so this is how your function, your graph would look. Can you guys see my screen properly?
Yes.
Okay.
It's clear.
No.
So it would look like, let me just draw a graph over here. Okay. Remember we said our x equals to negative, let's write our asymptotes, right? Our x equals to negative 4, our q equals to negative 3. Then x-intercept, our x, it intercepts the graph at negative 14 over 3. And then the y, these are the intercepts, right? And then the y at, sorry, negative 7 over 2. Now, when we look at the shape that our graph is supposed to take, we know for a fact it's supposed to go into the second quadrant and the fourth quadrant because it's a negative function. It's a negative hyperbola, right? So this is what's going to happen. This is not drawn according to scale, by the way. So let's just assume that over here you have your negative 4, right? And then over here, you have your y asymptote, which we said it was negative 3. Can somebody put this negative 14 divided by 3 into the calculator for me? Negative 14 divided by 3?
Negative 4,6.
Negative 4.6. So it would approximately be over here, right? Let's just do this. Then can you say negative 7 divided by 2 into the calculator for me?
Negative 3,5.
Negative.
Negative 3,5. So it would be, it's most likely to be here. Right. So now we have to now draw a hyperbola whereby the shapes of the graph, they touch our intercepts. So this one, it would take this function or this shape over here. I remember this is a hyperbola, so it's going to do this. And this one over here, it will come like this. Then, yo, sorry. But yeah, this way. It will never ever touch your asymptotes, right? So this is what your graphs would look like roughly. Of course, now it looks a little sketchy because it's not drawn according to scale. But if it was drawn according to scale, it would look proper. You guys get that?
Yes.
Okay, cool.
Yes.
Now I'm going to send another one, another question to the group. It's a question of my heart. You can Okay. Mm, mm, mm. We belong to anyone but you. Okay. Um, I sent it. Nah, maybe guys, please check them out, and let's look at what it's saying. Okay, let me read it out because it looks sort of clammed out. So we have question 5, and they're saying the graph of functions f of x equals to negative into brackets x plus 3 squared plus 4. And we know that x plus 3, it's what? It's a parabola. It's a downward facing parabola. Why? Because it has a negative, right? So we have, wait, let me just do this. So we have g of x, which is equals to negative x plus 3 squared. We know it's a downward facing parabola. Why? Because of this negative. Wait, it's what? Plus 4. Right? So what else? And then we have a straight line, g of x. Wait, this is f of x. Sorry. This is f of x. G of x, we have it as x. Is it x plus 3? X plus 5. Okay, fine. So we have these two, and then we have points of intersection at where? At A and B. So what we know about the points of intersection is that at A and B, those graphs, those two graphs, they're equal, right? That's what happens at the point of intersection. Where we intersect, it means we're equal at that point, right? So for 5.1, they're saying write down the coordinates of the turning point of F. Fine. Wait, guys, let me do this. So we know that if we have a hyperbola of this form, this right here and this, they're going to give us the turning points. But you need to be very careful with choosing the turning points, right? Remember, I said that this over here and this, because in a hyperbola, this function, it takes the form f of x equals to x plus p squared plus q. So this p and this q, they are the coordinates of our turning points, right? So, but when you have to find the coordinates of the turning point, this p, can you see that once it's in the bracket, it's plus p. Once you put it here as a separate coordinate, you have to say negative p, and the q will remain like this. It'll be like this. So now let's apply this over here. So can you see that we have a positive 3, the turning point of a, sorry, the turning point of a parabola? It's 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 given by these two. We have a positive 3. Remember, I said if you have a positive p, whatever that you have in here, it has to change its sign once you do what, once you put it outside, right? So it will be negative 3, and the q, which in this case it's the 4, remains the same. So you will have negative 3 and just 4. You guys get that, right? Yeah.
Yes.
Okay, great. Now let's look at so we know that that's the turning point. So basically like the maximum point. So on this graph over here, on the parabola, the one that we have like this, we know that the turning point, it's what? It's negative 3 and 4. Right? Now let's look at what 5.2 is saying to us. 5.2, they're saying write down the range of what? Of f. So we can see that this graph, it's coming from where? Because it looks something like this, right? It's coming from the negative infinity, right? It's coming from the negative infinity. And then, okay, it's coming from the negative infinity, hits positive 4, because remember, we're just talking about the y's because we're talking about the range. Hits the positive 4, and then it decreases once more, right? So its maximum point, it's this positive 4. It cannot go beyond the positive 4. We agree on that, right?
Yes.
Okay, so we're going to say that it starts from the negative infinity and then all to what? All to 4. Mhm. So you're going to say y is an element from negative infinity all to what? Stops at 4. And you have to include this 4. Unlike this, right? You have to include this 4 because it does indeed go through the 4. It does touch the 4. Right? The 4 is included. So for 5.3, they're saying that show that show that the coordinates of A and B are -5 and -2 respectfully. Remember, we said A and B are what? A and B are the points of intersection. Right? Let me just why to know. Remember, we said A and B are what? Intersection points. And we said that at the how do you write intersection? Intersect. Man, this is an intersection point. Nah? I don't know how to write that. So we said that at the intersection points, graph like f of x will be equals to what? It will be equals to g of x. So we have to equate the two together, right? So we're going to have negative x plus 3 squared plus 4 all being equals to what is our g of x? Our g of x is x plus 5. Okay, we can see that we need to solve whatever this is, right? Before we try anything else. So blah, blah, blah. This will just be what? Let's try and solve it over here. It'll be x plus 3, x plus 3. You can cross multiply. No, when you multiply into the brackets, not cross multiply, sorry. It'll be x squared plus 3x plus 3x plus 9. So you're going to have x squared plus 6x plus 9. So you're going to have negative and then open bracket x squared plus 3, no, plus 6x, sorry, excuse me, plus 9, close bracket, plus 4 equals to x plus 5. So we're going to have uh, negative x squared, negative 6x, negative 9 plus 4 equals to x plus 5, right? So now, okay, we have like times. Let's just solve it, Clary. Negative 5, right? Equals to x plus 5. Now, because we have a negative x squared, all that we can do is just transpose this whole thing to the other side, right? So we're going to be left with 0 equals to x squared plus 6x plus 5 plus x plus 5 again. So we'll have 0 equals to x squared, 6x plus this one, it'll be plus 7x plus 10. So far, you guys are with me, right?
Yes, we
Because
are.
all that we're trying to do is just find what A and B are with regards to their x values, right? So we have a 10 over here. I said if you're trying to factorize, we'll have two open brackets, equate them to 0. So place an x here, place an x here. We have to have m plus n equals to 7, m times n equals to 10. So when you add m and n, when you add the two factors that we're going to get, they should give you the middle term. But when you multiply them, they should give you 10. So we know that two things that we can add together and give us 7. And when we multiply them, it's and give us 10, it will be 5 and 2. Positive 5, positive 2. So we're going to have plus 5 plus 2. So now that we're here, we can just say x plus 5 equals to 0, or x plus 2 equals to 0. Therefore, our x will be equals to negative 5, or our x will be equals to negative 2. And remember that they said we should specify which one a will be. So we're going to say, therefore, a will be the one furthest. So a will carry the negative, right? It will be negative 5 and 0. And b will be negative 2 and 0. Right? Right?
Yes.
Okay. Now let's look at
Yes.
5.4. Okay, let's look at 5.4. Let me see what 5.4 is saying. 5.4, they're saying what? Okay, they're saying hence determine the values of C for which the equation has one negative value and one positive value. Okay, so let's look at our graph. Ne? Let's look at it, right? Because it's something of this nature. And then it has this over here. This point, let's say it's A, then this one it's B. We know that what is A? Negative 5 and 0. What is B? Negative 2 and 0. Right? Okay, cool. Um, so let's look at what they're saying. They're saying, hence determine the values of C for which the equation um will have what? One negative and one positive root. So when they say one negative and one positive, what they essentially just mean is that we should perform an operation on this graph that we currently have. Because when we look at this, this is the negative, this is the negative, right? So at the current moment, we have two negative roots, right? Because our graph, it's all based on the negative x-axis. So these two there are our negative roots. But what they say is that they want us to do something to this graph until we have what? One negative root and one positive root, right? So now, this is what's going to happen. If we want to have one positive or one negative, because this is already negative 2. If we shift it 2 units, okay, fine. This is already negative 2, remember? Ne? If we want to make this negative 2 a positive, we can do what? We can fight and shift it that direction so that it lies on the 0. Because at least this 0 is what? 0 is positive. It's not negative, right? So we have to perform um operations so that we can have this negative 2 at least being shifted 2 units to the right, so that what? So that it can have one positive. Because if we shift this negative 2 units to the right, it will be like over here and it will lie on the positive. So we'll have one positive root, and this one, even if, because this is negative 5, right? This is negative 5. If we shift negative 5 2 units to the right, it will be negative 3. It is still negative. So we will be correct because we will have one negative root and one positive root, right? Do you guys get this? Like, do you guys get where I'm going with this?
Yes.
Okay, fine. So
Yes.
now that we agree that we have to shift it 2 units to the right, right? So you're going to say, okay, sorry. I'm going to say shift, shift it 2 units to the right. So if we shift it 2 units to the right, what is the, because look at the question, right? Okay, they're saying, hence, wait, they say what? Hence determine the values of C for which the equation of that has one negative, one negative and one positive. Okay. We know that we should shift it in a way in which this two will lie on the positive, right? Okay. So this is what the C will look like. The C is going to have to be, sorry. The C will have to be greater than -2, but less than -5. Let me explain what I mean by this. Because remember, we're shifting it how? 2 units where to the left, to the right. I need you guys to know that if we are shifting, okay, it's contrary, like it's something that doesn't make sense. But if you want to represent a shift to the right, we represent it by a negative. Do you guys understand? Like it will be a -2 shift on the graph. As much as we shifted it to the right, because normally when like either when you're doing physics or something, when you think right, you think positive, right? But with relations to graphs, a -2 shift, it means a 2 unit shift to the right. You guys understand that?
Yes.
Okay, great. So here, what we basically mean is that the shift that we have to make, it should be greater than what? No, the shift, right? The shift that we make, it should be greater than 2, but less than 5 units to the right. Because if it's more than 5 units to the right, this 5, let's say it's, because wait, we're saying if it's more than 5, let's say it's now 6 units to the right, this 5 will no longer be in the negatives, but will be this side. And if the 5 is over here, it means that this b is over here. Now we have two positive roots, which will be incorrect. So what we're saying by this is that the shift that we're going to perform is that this -2, the shift should be greater than 2 units to the right, but less than -5 units to the right. Because if it's greater than -5 units to the right, then it's going to take our A, put it in the positive side, which is not something that we want. So all that we have to do is just shift our graph 2 units where to the right. So we have to just state it and say C should be greater than what? Than -2, but less than -5. Do you guys get that?
Yes.
Okay, thank you. Now let's go to the next one. Okay, they're saying, what? What are they saying? The maximum distance between F and G in the interval. What time is it? Okay. The maximum distance between F and G in the interval, sorry, XA less than X less than XB is K, right? So they're saying that the maximum distance is what is K. If H of X equals to G X plus K, remember that this K, it's what? It's the maximum distance between F and G, right? So wait. let's redraw this graph. So we know that we have this, right? It looks like. Then we have, is this how it looks? Yes, then we have, this is our F and this is our G. This is our turning point, and this is our A, and this is our B, right? So they're saying that, sorry, they're saying that the maximum distance between F and G, whereby X is greater than XA, X is greater than XA, but less than XB, is K. So when they start speaking about the maximum distance, you know that this is the maximum point of the parabola, I get this one over here. This is the peak, right? The maximum height, right, of the parabola. So this point going downward like this, just label it D. This D from the maximum turning point onto the G, that's what the maximum distance will be between the two graphs. In order to get the maximum distance between F and G, you just have to get the distance between the turning point and G. Do you guys get that? And when we, how can we get the how can we get the distance? We're going to say, because this is the upper function, right? This is the upper function. F of X is our upper function. So in order to get the distance, what we can say is F of X minus G of X, right? Do you guys get that? Hey guys,
Yes.
Yes.
do you guys get that? Like the maximum distance thing that you say if this
Yes.
is the maximum. Okay, great. So this is the formula that you're going to use to get what the maximum distance, right? So the maximum distance in this case will be what? It will be, what is our F of X? It was negative X plus 3 squared plus 4 minus X plus 5, right? So remember, we worked this out to be what? There was some way where we worked this out, man. It was negative X squared minus 6X minus 9. Negative X squared minus 6X minus 9. Then we're going to have a plus 4. Now, with this, it's going to be minus X minus 5, right? Because we're trying to find out the maximum distance. So let's make this look neater, group our like terms. Okay, so we're going to have what? We're going to have um negative X squared. This and this, it's going to give you a negative 7X, right? Negative 7X. And all these together will be negative 10. Am I correct? Is this what you guys are getting?
Yes.
Okay, great.
Yes.
So because remember, we said that this is the maximum distance, né? This is the um that is the function that you can use to find the maximum distance. But like, okay, let's read the question. They're saying the maximum distance between F and G in the interval that is K. If h of x equals to g of x plus k, determine the equation of h in the form h of x. Fine. In order to get something at its maximum point, ne, I'm going to give you a pro tip. At the maximum point, you'd have to find the derivative of that function. So if we have a function like this and we're trying to get this at the maximum, right? Because remember, this is just the distance formula. This is the distance equation between the two graphs, right? This is not the maximum distance yet. This is just the distance, the normal distance between the two. But if we're trying to find the maximum distance, in order to find the maximum distance, what do we have to do? Find the derivative first. So how can we find the derivative of this? We know that if we're finding a derivative, okay, let me just write this down. Because we have f of x as what? As, my stomach, negative 2 minus 7x minus 10, right? If we have to find a derivative, we know that we're going to take the exponent down. So it'll be what? Negative 2x, right? Minus 7. Do you guys understand how I found this derivative?
Yes. But
Yes.
Okay, you guys understand it, ne?
Yes.
Then from here, just equate. Let me just write downwards. Then you're going to say negative 2, because remember you're trying to, wait, because remember you're trying to find the maximum distance, right? So you're going to say negative 2x minus 7 will be equals to what? To 0. And then you're going to transpose this to the other side. So now you'll be left with negative 2x equals to what? Positive 7. Divide both sides by negative 2. So your x will be 7 divided by negative 2. You have found the x value that you can substitute over here in the distance formula in order to be able to find your y. And this y over here will be the maximum distance. So this is the x value at the maximum distance. So just take this x, substitute it into this formula to be able to find your y. So you're going to say y equals to negative 7 over 2. Wait, negative, is it negative? Yeah, negative squared minus
Yes.
7 all into negative 7 over 2 minus 10, right? So our y value will be
9 over
9
4.
over 4. 9 over 4. So this will be the maximum distance between the two functions. So remember, we're not done yet with the question. This is just the k. In this case, this is just the k because this is the maximum function, right? So it's our k. Let's look at what the question was saying exactly. They said the maximum distance between f and g is what? Is k, right? If h of x, so they're saying h of x equals to what? G of, can you guys see? So they're saying h of x equals to g of x plus k. We know that this k is what? The maximum distance. This gx, we already had it. This g was what? X plus 5. So it'll be x plus 5 plus 9 over 4. It'll be our h of x. So which means therefore h of x will be x plus 29 over 4.
You can add up.
You guys get that?
Yes. Mama na ka na sa lagi sa sa
Do you guys get that?
Yes.
Okay, great. Now I'm going to send I think it will be our, what time is it? Yeah, this might be our last one. Then where is it? Mm, yeah, but uh, okay. I just sent it to the group. Now, can you guys look at it? Okay, so it's question 6.1. Let's look at what it's saying to us. Né? So they're saying we're given a function g of x. So it's what? It's an exponential function, right? G of x, it's 3 raised to the power x, right? Remember how you can how you can differentiate these things is that if it's a parabola, it's most likely to be raised to a power 2. Yeah. And then if it's a parabola, it'll be raised to a power 2. If it's a hyperbola, it'll be in a fraction form. And if it's just raised to the power x, then you have what we call an exponential function, right? So for 6.1, they're saying we should find what the inverse of this. So in order to find the inverse, it's 6.1.1, right? Can you guys still see my screen? Okay. Um, if we have the inverse of x, sorry, man, we have, okay, this is essentially y equals to 3x. And if we want the inverse, we know that we have to swap these around, right? So this will be x equals to 3y. But we want to make the y the subject of the formula. So what can we do? Introduce logarithms. So we're going to have log x equals to log 3 raised to the power y. This log over here, it will bring down our y. So we'll have log x equals to y multiplied by log 3, which what? Then we can like divide both sides by log 3, divide this by log 3, right? Therefore, our y will be equals to, remember, if you have this 3 in the base, it will have to be your base as well. So you're going to have log base 3x as your what? As your inverse. So g inverse of x will just be log base 3x, right? Okay. Uh, okay. Now let's look at 1.6.1.2. So for 6.1.2, they're saying point P lies on that graph, on that exponential. The graph of H is translated to form G. Write down the coordinates of the image of P on G. Okay, wait, let me see. They're saying P, right, 6.1.2. So they're saying point P, which is 6 and 11, it lies where? It lies on that, on h of x. So we have point P, which is 6 and 11, and it lies on h of x, which is equals to 3 raised to the power x. Is it a plus 4 or minus 4? Minus 4 plus 2. The graph of h is translated to form G. So if we have, sorry about that. So they're saying that we have a point P and it's on this graph over here. Then they're telling us, sorry, and then they're telling us What? Okay, so we have a point P on this graph on over here, right? And then they're telling us that it has been translated to form what? G. So we have the original graph. Like when we look at this, we know that the okay, we know that what do we call this kind of an exponential graph? It just takes the form h of x equals to, let's say, 3x. But now that over here we have it, it's guys, that's kissing. Somebody was like in my room. So if we have 3x minus 4, we know that the original just looks like this, right? The original of what? An exponential. So if we have a negative 4 over here, what does this negative 4 mean? It means that our graph, it has been shifted how? So this x, it shows a shift, right? It has been shifted 4 units to the right. Remember in the previous question I said, even though like it's hard to process and a hard pill to swallow, that a negative could be talking about the right. Just know that when we are talking about graphs and you see a negative, just know that it's a graph that's negatively shifted to the it's shifted. If it's a negative, it's being shifted to the right. So over here, because we know that an original exponential graph, it just have it just has x. This negative 4, it shows that it's been shifted 4 units right. So the exponent part of this, like it shows a shift to whether it was that way or that way. But once we start having constants over here, like +2, +3, plus whatever, it means that now it's showing a shift either what? Up or down. And this +2 per use, it shows what? A 2 unit shift upward. So they shifted this graph 4 units to the right and 2 units upward. Do you guys get that?
Yes.
Okay, fine. So what they're trying to know now is that how, because remember, what the hell? Remember, we have P. This is our P over here, right? We have P on this one. But they want to know that once it has been, how did they say? Once it has been what? Transcribed or what? Trans translated. Once it has been translated, how will this P point look? Remember, we said we moved what? We moved 4 units to the right and 2 units up. So who's trying to join at this time? At this time. Oh, it's Rekhumulis. Mm, my goodness, what the heck? Okay, so fine. Now we have to explain how it being translated is going to have an effect on this. Remember, we said that we have it was shifted 4 units where to the right, and it has been shifted 2 units how? Um 2 units up. So once they say it's translated, it means show us how it was in its former position before it experienced this 4 units right and 2 units up shift. How was it? So we'll just do this because This part it relates to what our x-axis. This part it relates to what our y-axis. And for the p, this is our x. This is our y. So if we have a 6 and it's been shifted 4 units right, so which means we had this and it was shifted 1, 2, 3, 4 units further right, which means that initially it was over here. And if we are here at B and we're trying to find our way back and it has been shifted 4 units right, in order to find it, we can just say -4, right? So we can say 6 minus 4, we'll be able to find out what it was initially, right? And if now it's 11 because it has been shifted 2 units upward, what we can just do is what? Say -2 to this 11 because now it'll bring it down 2 units down. Do you get it? So now our P will become what? Our P will become 2 and what is 11 minus 2 and 9?
Sorry,
So
aren't you supposed to minus 4 from the 6?
yes,
Oh,
I did.
yeah.
I said 4 minus and give me this.
Yes, I can see.
Okay. Yes. So yeah, that's that part. Olele. Okay. Now let's look at the other question. What does it say? Mm. Is there another question? Or did they end by 6.1.2?
So the thing is, right now, I can't check the questions because I can't share the screen because my phone is overheating at the moment.
Oh, okay. I think because I'm only just seeing it until this point over here. I think let me just check. Nah, they end here. So which means if they end here, okay. Then that was the end of our class, ne? So far, do
Yes,
you understand everything that we have touched on here?
yes.
Oh, okay, great.
But is it
And
possible for me to still get the past lessons of functions?
yeah, problem with that is that I only like we only started recording after that class happened, right? So that class happened and it just, yeah, it just went by. But what I'm planning on doing is that I want to, but this will be during the weekend, to be honest, because tomorrow I have grade 11s and on Friday I also have another class with grade 11s. So during the weekend, that's the only time I'll be able to record for functions and then post it.
Yes.
Okay.
Okay, I have another question,
Okay.
but it's not based on this lesson.
Okay. No problem.
So, okay, when are we having another class for maths and when are we having the other one for physics?
Okay, we have our physics class every Monday. Then what day is it today? Then our maths class it's every Wednesday. But for people that are rewriting, um I said that starting from the 20th, that week, yeah, the 20th, yeah, February, that's when we'll start having like one extra for every day. So we'll have two for physics per week and we'll have two for maths per week. But for now, we still have to operate like this, one because I haven't sorted out like the timetable properly. But around the 20th, but that's only for people that are upgrading. That's when we'll start having 2 times in a week.
So on weekends we don't have classes.
On weekends we don't, unless if I say, may we please meet on Sunday, and it's always on Sunday because on Saturdays I work.
Yes,
So
I
it's
understand.
normally on Sundays. Yeah, like last week we had a class on Sunday.
Thank you.
Okay. Um, yeah. Is there anything else? Okay, and another thing, feel free to ask me any questions on any given time. Ne? So let's say you're practicing, you're home, and there's something that you don't understand. You can just tell me. And let's say there's a topic that you're doing, but we are currently not doing it. Let's say you're doing trigonometry ne, right now, but we're not doing trigonometry in class. You can just tell me, and you and I will decide, "Hore, okay, fine, we can maybe have a one-on-one session, but provided that you're free in the morning, that's when I prefer having those because around these times I have to now do that last thing. So if you're free, then we can like meet up, same thing using Teams again, and then we'd be able to discuss that and thoroughly do it. And I advise people that are rewriting to do that. Like, don't just focus on what we're doing. If you feel like you want to do a certain topic with me already, just tell me, then we'll schedule the time for it.
So the only topic that has been covered, it's only functions for now.
No, we did functions, we also did exponents and surds. So we're left with number patterns and paper two.
Probability and finance.
No, we haven't done probability and finance yet.
Okay,
Yeah.
thank you.
Okay. Thank you very much. Okay, bye na.
Bye. Thank you very much.
Chapsha.